The line segment joining the points in bracket 1, 2 and in bracket 5, 6 is divided by the point 3, 4. What is the ratio in which the point divides the segment? Solution. The section formula state that if a point P with coordinate of x, y divides the line segment joining the points A of coordinate x1, y1 and B of coordinate x2, y2 in the ratio m to n, then x is equal to m times x2 plus n times x1 over m plus n, y is equal to m times y2 plus n times y1 over m plus n. In this case, a coordinate 1, 2 which is coordinate x1, y1. B coordinate 5, 6 which is coordinate x2, y2. Point P of coordinate 3, 4 which is coordinate of x, y. Let P divide the segment in the ratio m to n, then we have 3 is equal to m times 5 plus n times 1 over m plus n, and 4 is equal to m times 6 plus n times 2 over m plus n, solving for m and n. 1. From the first equation we have 3 times m plus n is equal to 5 times m plus n. 3 times m plus 3 times n is equal to 5 times m plus n. 3 times n minus n is equal to 5 times m minus 3 times m. 2 times n is equal to 2 times m, n is equal to m. This means the ratio m to n is equal to in the ratio 1 to 1. Second. From the second equation substituting n is equal to m we have 4 times m plus n is equal to 6 times m plus 2 times n. 4 times m plus m is equal to 6m plus 2m. 4 times m plus 4 times m is equal 6 times m plus 2 times m. 8 times m is equal to 8 times m. This confirms our previous result. Conclusion. The point of coordinate 3, 4 divides the segment joining coordinate of 1, 2 and coordinate of 5, 6 in the ratio 1 to 1. Let f of x is equal to 1 over x. Then find the area of triangle formed by coordinate axes and the line tangent to the graph of f at a, 1 over a. Solution. Step 1. Find the derivative of f of x. We can rewrite f of x as f of x is equal to x raised to -1. Now, applying the power rule, the derivative of f of x is equal to -x raised to -2, which is equal to -1 over x squared. Step 2. Evaluate the derivative at x is equal to a. The derivative of f at a is equal to -1 over a squared. This gives us the slope of the tangent line at the point a, 1 over a. Step 3. Write the equation of the tangent line. The equation of a line in point slope form is given by y minus y1 is equal to m times in bracket x minus x1. Substituting in our values where m is equal to the derivative of f at a is equal to -1 over a squared, x1 is equal to a, and y1 is equal to 1 over a, we have y minus 1 over a is equal to -1 over a squared times in bracket x minus a. Rearranging this equation gives y minus 1 over a is equal to -1 over a squared times x plus 1 over a. Y is equal to -1 over a squared times x plus 2 over a. Step 4. Find intercepts with coordinate axes. To find where this line intersect the x-axis, where y is equal to 0, that is setting y is equal to 0. Then 0 is equal to -1 over a squared times x plus 2 over a. Solving for x. We have -1 over a square times x is equal to -2 over a, and multiply both sides by -a squared. We have x is equal to 2 times a. Now to find where it intersect the y-axis, where x is equal to 0, setting x is equal to 0. Y is equal to -0 plus 2 over a is equal to 2 over a. Thus we have 2 points of intersection. X-intercept is 2 times a, 0. Y-intercept is 0, 2 over a. Step 5. Calculate area of triangle formed by this intercepts and the origin. The area, A, of a triangle formed by vertices at points on coordinate axes can be calculated. The triangle so formed is a right-angled triangle of base length is 2 times a and height is equal to 2 over a. Therefore, area is equal to 1 over 2 times base times height. Area is equal to 1 over 2 times 2 times A, times 2 over A, cancelling like terms. The area is equal to 2. Therefore, the area of the triangle formed by coordinates axis and the tangent line is 2 square units.